In this question from JEST 2013, we have an observer. In the observer's rest frame, let's say this is S frame, there is a particle which is coming in this direction with energy E and momentum P. So this is observer's rest frame. S frame is observer's rest frame. In that frame, a particle is moving with energy E and momentum P. Now there is another frame, let's say a vehicle. It is moving with velocity v in the same direction as the particle. Let's say this is S prime frame. We have to calculate the energy of the particle as viewed from the S prime frame. To find the energy in the S prime frame, which is moving with velocity v in the same direction as the particle, we can use the energy momentum transformation formula. Energy momentum transformation formula. If there is a particle and its energy and momentum are E, Px, Py, Pz in a particular frame S. S is an inertial frame. When viewed from S, the energy of the particle is E and momentum components are Px, Py and Pz. Now there is another frame which is moving with velocity v. Let's say this frame is S prime. It is moving with velocity v in the x-axis direction, positive x-axis direction. Then when viewed from the S prime, energy is E prime, Px prime, Py prime, Pz prime. This is the momenta and energy of the particle when viewed from S prime. The relation between E prime and E is E prime is equal to E minus Px v times gamma. Px prime is equal to Px minus E into v upon c square times gamma. Py prime is equal to Py. Pz prime is equal to Pz. Because the motion of S prime is along the x-axis direction, the components of momenta along y-axis and z-axis remain unchanged in both the inertial frames. When we apply this energy momentum transformation formula in this problem, we will get E prime is equal to E minus PV into gamma. Gamma is 1 by root of 1 minus v square upon c square, which can be written as 1 minus v by c the whole square. Therefore, the correct option here is option B.